Hello, today we are going to discuss section 2.2. I think you'll like this section. We use it a lot in this course. So let's jump in and work on section 2.2. Let me change my cameras and make sure we're focused here. The first thing we're going to do is the distributive property. You've probably seen the distributive property before somewhere in your background. It's a property we use almost every time we do an exercise. So let's look at it. The parentheses means times, and there's a quantity inside, B plus C. To use the distributive property, you're multiplying the number or letter outside by what is inside. So you're going to each one of them and distribute. So the first one will be A times B, and then you say plus A times C. For a problem that we would be using like this, it would be something like 3 times x plus 2. So you take your 3 and you multiply it by the x, and you get 3x, and the 3 and multiply it by the 2, and you get 3 times 2 is 6. So that would be your answer. You can't combine because the 6 does not have an x on it. One of the hardest things for students is when there's just a minus out there in front and you really don't know what to do with that. So this is an example from one of your problems that you'll be doing in this section. There's just a minus out there. You can put a 1 in front if you want a number. That will help you distribute it. Remember that the negative acts as an opposite maker, so what it will do is change each one of your signs that's inside. Now the 22 is considered positive at this point, a positive 22. So when I multiply it by -1 times positive 22 will be negative 22. See how it changes the sign on it? The -1 times the positive 34 will change that plus to a negative. So then I have negative 34b. And then this negative times this negative will make a positive. It'll change this negative to a positive. 1 times 9 is 9. So that would be the answer. I can't combine any of those terms. There will be a section where we will be combining like terms. For instance, if you have 9x minus 6 times 3x minus 4, then minus 4 on the outside, this is the part you want to be concerned with, multiplying the -6 times each of these members inside this parentheses. So this will be the tricky part right here. The 9x just comes down. You don't do anything with it until you find out what you have in the middle. You have to get rid of the parentheses by saying the negative. Remember, the negative will act as an opposite maker here. 6 times 3 is 18, so this will be a negative 18x because the 3 was positive, and now it's going to be negative. The negative times that negative, like an opposite maker, it will change that to a plus. 6 times 4 is 24. And this doesn't have anything to do with the parentheses, so I just bring it down. Now then, I'm looking for terms that look alike. So I'm looking for instance, things that have an x on it. So I have a 9x and I have a negative 18x. Now in this case, I'm combining like terms. So if you think of this, there are more negative numbers than there are positive numbers. So you would subtract the numbers, and then your answer would be negative because there's more of them. It's kind of like having $9 in the bank and you write a check for $18. You're going to be $9 in the hole. So that gives me a negative 9x. And then these two are the same kind. 24 minus 4 would give us 20, and there's more positives than negatives, so I have plus 20. So my answer is negative 9x plus 20. Now let's talk about some definitions that we have in this section. Relation is the first one. A relation is any set of ordered pairs Or you could say it's any graph, any picture, any graph that you have. That's is really called a relation. Then there's a special one that we use all the time. This is called the function. Function. F-U-N-C-T-I-O-N. Function. Let me rewrite that. I almost said domain, which is one of the ones we're about to use, but function goes with relation. Domain goes with range. So function is one that we're going to be using a lot of. It's very important to know what a function is. A function is a relation, so it's a set of ordered pairs that associates every element of the first set, which is the set of x's, with exactly one element of the second set and the second set is the y values. So a function is a relation that associates every element of the first set, which is called the x values, or the domain, we'll learn in just a moment, with exactly one element of the second set, which is the y values, or the range. So that's one of our most important definitions that we have in class, is the definition of function. You'll need to know this part of it, the definition, for one of the problems that you'll be doing in class. All right, let's go to the next set of information. This is the one that has the word domain. Domain is used a bunch in this class. We do it all the time. It is the set of x values. Okay? It's the first set, the set of x values. It's the first set in the ordered pair. Range is the other part of it, and of course, that is the set of y values, or the second set. Let's do an example. If I have a set and these little braces indicate a set of ordered pairs, which would just be a relation to start with, and then we can determine if it might be a function in just a minute. So we have a set of 4 ordered pairs. They're just four little dots or 4 little points on your graph. But you can look at them and you could find out what the domain is and what the range is. So if we look at domain, we see it's the set of x values. So I'm going to do the little squiggly bars, which is a brace, and I just write down the set of x values: 0, 1, 3, and 6, using just the first number of each ordered pair, which would be the set of x values. Then the second one is the range, which will be the set of y values. So I have 3, 5, 4, and this one's 5, and I already have a 5 here, so I don't have to rewrite the 5. So now I have my domain and my range. The next thing they will want to know is this a function? Is this a function? Okay, well, if you look at your definition of function, then what it says is that a relation is a function that associates every element of the first set, which in our case will be the domain, with exactly one element of the second set, which is the y values or the range. So let's look. What that means is, are the x values all different. So let's check them out. Here's a 0 that's paired with 3, a 1 that's paired with 5, a 3 that's paired with 4, and a 6 that's paired with 5. I can see that all of those are different numbers. So my answer to this question would be yes, this is a function. Now let's do another example and we'll do the same thing. Example 2. We have another set of ordered pairs. Negative 4, 2, 4, 2, 8, 3, and 4, 0. And they want to know what is the domain and what is the range? And is this a function? Those are the 3 questions that they will ask. Okay, so the domain, so we'll go through here and just look at the x values. I have negative 4 and 4 and 8 and 4, but I already have 4 listed, so I don't have to rewrite that 4. The range would be 2, I already have the 2, 3, and 0. That's the set of y values. Now then, I check out the x's to see if they're all different. And I see that I have a 4 here and a 4 here. That messes it up because I have 2 that have a 4 listed as part of the domain there. So this would prevent, because the x's are not all different, this keeps it from being a function, so it's no. The x values are not all different numbers. Okay. Now there is a way to tell if something is a function or not just from the graph. So let's look at those. Let's do some graphs. This one is our parabola that we've been using. It's called quadratic function. Here is a line. This is an example of an absolute value. And we also have a rational function that we've been using. We've been looking at. We haven't really used it yet. Looks kind of like that. And let's see what else. Oh, cubic. We've done a cubic. So let's look at those. To determine from a graph whether or not it is a function, you can use a vertical line test. And that says for every vertical line you draw, if it crosses the graph in only one place, then the graph is a function. All right, so the vertical line test, I'm going to change my pen color and show you how this works. If you draw a vertical line down the graph, you check how many places it crosses. Oh, that one's just one. Do it again if you want to, and for every vertical line that you draw, it only crosses in one place. So this one is a function. Same thing is true with your line. It is a function. It only crosses in one place for every vertical line that I draw. For absolute value, same thing is true. That is a function. That's why these graphs are graphs that we use all the time because this book is about functions. For this one, it kind of looks like it might cross it in more than one place there, but very, very slowly it's moving out. So it does not. So this is a function as well. And our cubic is a function. Well, if all of those are function, what does one look like that's not a function? So let's see. If we had a sideways parabola, or if we had like an oval, or we had something that looked like maybe this, then we can see that those are not functions, because if I drew a vertical line, I could see that it is crossing in two places there. So this one's not a function. On this one, for every vertical line that I draw, and I only need one, I can see that it's crossing in more than one spot. So it's not a function. And if these are straight up and down right here, then I can see that there's a bunch of places that this is crossing. This is straight up and down. There's a bunch of places. So this one is not a function. Now we're going to do a graph that's similar to this, but it slants. It slants. It's not straight up and down. We will do some step functions at some point, or it will have nothing in between here. We'll run into those a little bit later. They're called step functions. And in those cases, we'll have a graph that does not have this little section in here that's straight up and down, and it will make a function. All right, that's what you'll be doing for your assignment. I hope you enjoy your assignment today. It doesn't take very long to do it, and I will see you guys in class. Thank you so much. Bye-bye.